Have you ever wondered what it's like to step into another world without leaving your living room? Welcome to the world of virtual reality. This is a realm where the lines between the physical and the digital blur, where you can scale mountaintops, explore alien planets, or even walk through the annals of history, all from the comfort of your own home. Virtual reality, or VR as it's more commonly known, creates immersive experiences that make us question what's real and what's not. It's a technology that has captured the imagination of millions around the globe, revolutionizing not only the world of gaming, but also permeating into fields as diverse as education and healthcare. The growth and popularity of VR are undeniable, but as we stand on the precipice of this digital frontier, it's worth taking a moment to understand the science that underpins this incredible technology. Now, before we dive deeper, do you know how this fascinating technology works? Virtual reality, or VR, isn't magic. It's a clever use of various technologies to trick our senses into believing we're in a different environment. Let's take a moment to appreciate the science behind this fascinating technology. At the heart of VR lies computer technology, not just any computer technology, but ones that are powerful enough to create a convincing, three-dimensional world. This world is a simulated environment that users can manipulate and explore. But how does this happen? Well, the answer lies in the realm of computer graphics, specifically 3D modeling and rendering. These are the processes by which a computer generates a three-dimensional scene from a mathematical representation. First, 3D models of the virtual world are created. These models represent objects and environments just as they would appear in the real world, but in a digital format. The models are then textured and lit to mimic real-world materials and lighting conditions. This step is crucial as it adds the necessary details that make the virtual world look real. Next comes rendering. This is when the computer generates an image from the 3D model. It's a complex process that involves calculating how light interacts with the objects in the scene. The computer has to consider the color and texture of each object, the direction and intensity of light sources, and even how light bounces off one object and onto another. This whole process happens in real time, generating new images as the user moves around and interacts with the virtual environment. That's why powerful processors and graphics cards are essential for a smooth VR experience. Now, creating a believable virtual world is one thing, but making the user feel like they're actually there, that's a whole different ballgame. To achieve this, VR systems use a range of sensory feedback mechanisms. These include visual displays that cover the user's field of view, audio systems that provide 3D sound, and sometimes even tactile feedback devices that simulate touch. Interesting, isn't it? But how does VR manage to fool our senses so convincingly? Our senses are incredibly precise and accurate, but VR technology has found a way to deceive them. Imagine standing atop a towering skyscraper, looking down at the bustling city below. Your heart races, your palms sweat, but you're not really there. You're in your living room wearing a VR headset. How does this happen? The illusion begins with a stereoscopic display. This technology uses two slightly different images, one for each eye, to create an illusion of depth. Just like in the real world, objects closer to you appear larger and those far away seem smaller. The images are then updated in real time, providing you with a seamless, immersive experience. But the deception doesn't stop there. To create a sense of spatial awareness, VR employs tracking sensors. These sensors monitor your head and body movements, translating them into the virtual world. Turn your head to the left, and the virtual scene shifts accordingly. Reach out your hand and you see your virtual hand extending. This connection between your physical movement and the virtual response is what makes VR so convincing, yet there's more to it. VR also uses techniques like parallax and perspective. Parallax is the apparent shift in position of an object when you look at it from different angles. In VR, it's used to give a sense of depth and distance. Perspective, on the other hand, is all about how objects appear to the eye based on their spatial attributes. Together, these techniques trick your brain into believing you're in a different reality. To complete the illusion, VR utilizes auditory cues. By adjusting the volume, pitch, and direction of sounds, VR creates a 3D soundscape that complements the visual experience. Hear a bird chirping to your right, and you'll instinctively turn your head to look. So you see, it's all a grand illusion. a symphony of visual, auditory, and sensory tricks that convince your brain you're somewhere you're not. All these elements work together, fooling your senses, immersing you in a virtual world that feels incredibly real. If you've ever used a VR system, you know that you can touch and interact with objects in the virtual world. Now let's delve into the magic that makes this possible: haptic feedback technology. This is the science behind the tactile sensations you experience in the virtual realm. Quite fascinating, isn't it? Haptic feedback, in its essence, is a technology that recreates the sense of touch by applying forces, vibrations, or motions to the user. This tactile information is critical in many applications, including gaming and training simulations, where physical touch provides a new layer of immersion. Imagine picking up a virtual glass of water. With haptic feedback, you can actually feel the weight of the glass, the cool surface against your skin, and even the liquid sloshing around inside. This is achieved through advanced hardware such as haptic gloves and suits, which use a variety of mechanisms, including pressure points, resistance motors, and temperature controls. This technology is not only enhancing the realism of the VR experience, but also opening up new possibilities. Designers and architects can feel their creations, surgeons can practice complex procedures, and gamers can engage more fully in their virtual worlds. But the question remains, how far can we push this technology? Can we eventually replicate every sensation we experience in the real world? That's an enticing thought, isn't it? So, we've seen how VR can trick our senses, but where is this technology headed? The future of VR is more exciting than you might imagine. As we stand on the precipice of a new era, the horizon of virtual reality is expanding at an exhilarating pace. The advancements in VR technology are pushing the boundaries of what we once thought possible. And it's an exciting time to be alive. Imagine for a moment the sensory feedback in VR becoming so sophisticated that you could touch and feel virtual objects as if they were real. The latest haptic technology is already making strides in this direction, but future iterations of VR could take this to a whole new level. Imagine feeling the texture of virtual surfaces, the weight of virtual objects, or even the warmth of a virtual sun on your skin. This level of immersion could truly blur the line between the virtual and the real. And let's not forget about the visuals. The graphics in VR are already impressive, but they're set to get even better. With advancements in rendering technology, we're looking at a future where virtual worlds are indistinguishable from our own. The level of detail, the lighting, the reflections, they could all be so realistic that you could lose yourself in these virtual environments. But VR isn't just about gaming. It has the potential to revolutionize a vast array of fields. In education, VR could provide immersive learning experiences, transporting students to different eras or even different planets. In medicine, it could be used for surgical training or therapy. In architecture, VR could allow us to walk through buildings before they're even built. The list goes on. The future of VR is a world where our physical and virtual realities are seamlessly intertwined. A world where we can explore, learn, and create in ways we've never been able to before. A world where our imaginations are the only limit. The possibilities are endless, and we're just at the beginning of this incredible journey. Virtual reality is more than just a gaming tool. It's a transformative technology. It's an intricate blend of science, engineering, and imagination that has the potential to reshape our world. Let's take a moment to revisit what we've covered today. We started by exploring the reality of virtual reality, delving into the essence of this cutting-edge technology. It's not just about creating a convincing illusion of reality, but about immersing us in a completely different world, a world that's limited only by our imagination. Then we took a deep dive into the science behind VR. We discussed how it leverages the principles of optics, computer science, and human perception to create a convincing virtual environment. It's a testament to our understanding of the world and our ability to mimic its intricacies. We delved into how VR tricks our senses, creating the illusion of being in a different place. By manipulating visual, auditory, and even haptic cues, VR can make us feel like we're climbing Mount Everest, exploring the depths of the ocean, or walking on the moon. We also took a glance at the future of virtual reality. With advancements in technology and increasing accessibility, VR has the potential to revolutionize not just gaming, but also education, healthcare, and many other fields. The next time you put on a VR headset, remember the amazing science that makes your virtual adventure possible. Until next time, keep exploring.